Good day. What do you say? Hey, want to play? It's almost the month of May. I don't know. It's time to do exponential logarithmic equations. Couldn't rhyme anymore. Sorry about that. Let's see how this microphone and this sound works. So, something like 2 to the x power equals 8, pretty easy to do. You're basically asking yourself, 2 how many times gives you 8? Well, 2 times 2 is 4, times another 2 is 8, so x would be 3. That's pretty straightforward and easy to get to. So let's say x equals 3 on that one, right? Well, what do you do when you get something like 7 to the x equals 132? Well, I know that 7 squared is 49, and I know that 7 to the third power is 343. So it's got to be between those two numbers, but what is it? Well, that's where we need logarithms. This is exactly why we use logarithms, is whenever our variable is the power, and of course when it's not easy to do in our head, but we can also solve this one with logarithms. So the whole idea here is, let's go right back to the definition of a logarithm. Remember, the base to the x power equals y if and only if log base b of y equals x. So in a problem like this, what we're really looking at is log base 7 of 132. And now you've got x isolated. It's by itself. Now we can solve it. But the problem is that base 7, we don't have a key for that in our calculator for most calculators. So we've got to have what we call the change of base formula. And the change of base formula looks like this. If we've got something like log, that's not an L, log base b of m, we can change that into log of any base you want. So let's call that c of m divided by log of the same base that you chose, c, for choice, of b. So now here's the question. What base would you want to choose? Well, there's really two bases. We've reviewed one of them we would use right now, but the other one's just as well, just as easy, gives you just the exact same answer. So in this case, right now, we know the common log. We would choose log base 10. So let's just do common log of m over common log of b. Remember, I didn't have to write a base because that's the common log, and that's implied to be 10. So that's what you can use your calculator for. If you want to, a little precursor here is to realize we can choose base e as well, which gives us natural log of m divided by the natural log of b. So, back over here to this problem. We've got this log with a base that doesn't work in our calculator. But if we choose the change of base formula and choose log base 10, common log, we would do 132 over the log, common log, of 7. Now, notice, the one that's in the numerator is the one that was here, the higher one. The base is the denominator's log. Okay? So, if you go put this in your calculator, it's going to look like this. You're going to go ahead and select the common log button. It's going to give you a parenthesis. You're going to put 132. You're going to close that parenthesis, and then you're going to divide with a new common log, which starts a new parenthesis. Put the 7 in it, close it, and get your answer. So we go ahead and do that, and we end up finding that x is equal to 2.509263814 ... right? So x is approximately 2.509. Okay? So you could put that back in your calculator, not as a rounded number, but use the answer key and go ahead and do 7 to that power and see that you get exactly 132. So again, remember, this is why we have logarithms, is so that we can do that. So let's go ahead and shrink this up really quickly. Make this just a little smaller. Get that out of our way a little bit. Bye, I'm shrinking. And let's try a little bit more difficult problem. Not very much more difficult, but a little bit. Let's take 4 to the 2x minus 3 power. So now we've got a little bit of an expression in there with our variable equals 132. So now we're trying to find 4 to what power is 132. No longer is it 7. So this is a different problem altogether. And our variable is in the power, but it's a whole expression. So what we're going to do here, again, this is in exponential form. Let's rewrite it in logarithmic form and see what we get. So if we do that, we end up getting log base 4 of 132. That equals your power, 2x minus 3. So notice x is now off the power, and it's come down. We can now isolate x with the algebra we know. Add the 3 to both sides. And notice the 3 is not going to add to the 132. It's got to add to the whole logarithm. Okay, so let's go ahead and come on up over here with that problem. We end up with log base 4 of 132. And we can go ahead and add 3 to that. Notice there are no parentheses. This is still going to equal 2x. Now, this plus 3 does not apply here. The only way to do that would have been to put a parenthesis. Now it would have been log base 4 of 135. But that's not what we're doing. We're doing that problem. Next, we're going to get rid of the 2 by, you guessed it, divide out the 2. Divide out the 2. Cancel that here. And we end up with x equaling, oops, let's move that over just a little bit, because I want to have space to write this for you. So x equals that. So what I want to do is let's go ahead and put it in the way we put it in our calculator. So first we got to do this whole denominator. So if I do log, and I have to do change of base, parenthesis 132, close, divide by log of, what is that, 4? What is that? All of that we have to add a 3 to it before we divide. Let's go ahead and take all of that, and let's go ahead and put plus 3. Then all of that has to be combined before we divide by 2. So one more set of parentheses, and we get our plus 2. So if we put all of that into our calculator, click, 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 tick, 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 yada, 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 we end up with y equaling, sorry, not y, but x equaling 3.26, 109, 853. Or in other words, approximately 3.261. You put that rounded number in, you're going to get very close, but you use the second answer key and plug it back in right there. You'll see you get 132. So those were all problems going from exponential form, you'll notice, going into logarithmic form to solve it using this change of base formula. Change of base formula is very helpful. What we're going to do next, and then we'll be done, is let's go the other direction. Let's get a logarithmic equation and change it to exponential to solve it. So if you're looking at this first one, yeah, it's easy. The definition of a logarithm tells us the base to the answer power equals the of number. So that's really saying 3 squared equals x. What's 3 squared? Yeah, you know that. 3 times 3 is 9. So right there, log base 3 of 9 would be 2. So 3 to the second power equals 9. Down here, slightly more difficult. I say that with kind of because just use the definition of a logarithm here, right? 5 to the 3.2 power equals x. Well, we can do 3.2 in our calculator, can't we? That's really easy to do. So 5 to the 3.2 power, and we get 172.4662077 or we'll say x is approximately 172.47. Okay? But, we can always get just a little bit more difficult here, nothing too crazy. Let's go ahead and try this problem. So what if we have 3 times the log of x plus 4 equals 6. Now, what kind of log is that I drew? Yeah, that's a common log. So what was the automatic base? What's the implied base? Yep, it's a 10. So before we can apply the definition of a logarithm, which I know you'll want to, before we can do that, we've got to move this 3 out of the way. We've got to have the log by itself. So how is the 3 connected to the log? Yeah, it's connected by multiplication right there. And we're going to get rid of it by dividing. So we divide out. 3 divided by 3 is 1. We still have common log, so I'll write it right now because we're going to need it in a few minutes. Common log base 10 of x plus 4. Notice this is in parentheses, so that's your whole of number, equals 6 divided by 3. We can simplify to a nice cool 2. Well, now we use the definition of a logarithm. And at this point, we realize it's going to be the base to the answer power, or 10 squared. 10 to the second power equals x plus 4. X plus 4. So simplify 10 squared, because order of operations, we would do our square first, our exponent first. So 10 squared is 100 equals x plus 4. Yep, you got it. Subtract out that 4. And now cancel that 4 out. We've got our answer. X equals 96. So notice sometimes we get a nice, easy, cool number. Of course, that's because of the example that I wrote. Sometimes we can get to our crazy, irrational decimal that goes on forever, and we'll end up with a rounded number. But you can use your second answer key in your calculator to double-check that. So there's your change of base formula with logarithmic and exponential equations, folks. I hope this helps. If you have any questions, I'll see you in the video conference, and enjoy, stay healthy. Bye-bye.